guys, welcome to my channel Subhas classes. Today we are going to the part 2 of permutation combinations. In the chapter, in the last chapter what we discussed was about counting principles. What are counting principles? What are the two parts? How to count the number of relations and functions between two that can be formed between two sets. When one set contains about n elements and the other contains m elements, what will be the number of relations between the two sets, and what will be the number of functions between two sets. That was the point in which we were just discussing that the number of relations was mn, just the product of the cardinalities of the two sets, while the number of functions was the power of the second set elements raised to the cardinality of the first set elements. In short, number of relations and functions when there were two sets A and B. This set contained n elements, this set contained m elements. Then if there was a relation established between them, either a relation or a function, if we mention f as a relation or a function, when it is a relation, the total number of relations was m into n, cardinality of the second into cardinality of the first, while the number of functions was m to the power n, the power of the cardinality of the set B raised to the cardinality of set A. That means how to apply this, how counting principle is applied in problems, in elements, in the book, elements book, in the bureau book. You have a problem. In the first two problems, you have, it is mentioned that take the problem from the examples and solve it, where there were two sets. If the first set contains two elements 1 and 2, the second set contains A, B and C, then we can mention this set to be A, this set to be B, and we know exactly that the Cartesian product A cross B has cardinality about cardinality of A into cardinality of B, which is 2 into 3 is equal to 6, and this is exactly the number of relations m into n. Here you can see that m is equal to 3 and n is equal to 2. So this is the number of relations, while number of functions which is m to the power n, so this will be 3 square, which is 9. So why the number of relations is differing from the number of functions? Because when you have to find the pre-images of the elements in second set B. I am talking in terms of the language of relations and functions. When you have the sets in this form, say 1 and 2 here, A, B, C are here, and I am just connecting these two. So if 1 and 2 are objects, then A, B, C, out of these three, A and C are the images of 1 and 2. So you can write here, if relation is f here, you can write f of 1 is A and f of 2 is C. So A and C are known as images of 1 and 2. And what are 1 and 2 called? 1 is f inverse A and 2 is f inverse of C. These are called pre-images. In that chapter also you study about domains and ranges, and we are not talking on that because that is not under the syllabus of this part. So we are talking of the pre-images. When there are three elements here, every element can have two images, two pre-images, and when you have two objects here, everyone can have 3. One can be connected to A, B and C, while 2 can be connected to A, B and C. So all the 3 here have each one has 2 images. Since A is having 2 images, B is having 2 images, C is having 2 images. So if you count the images, there will be 2 plus 2 plus 2, which is 2 into 3 and 6. But when you think that these 3 can be 3 pre-images, A has 2 pre-images, B has 2 pre-images, C has 2 pre-images. So when we multiply them, we can have A having 2 pre-images, so we can take them as 2 into 2 into 2, so which can be 2q. Or if we have one object has 3 images, the other has 3 images, so 3 into 3 makes 3 square, which is 9. So this is the pattern how we study the relations and functions that exist between two sets. So let us go for the second kind of problem. This was just a revision of the previous class, and in this class we are going to talk on how counting principle can be used to solve some problems like the road problem. There were 5 different cities, say A, B, C, D and E. There were 5 cities. How to connect these 5 cities by roads? What will be the number of roads required to connect each city with the other? So in using the counting principle, how many roads will connect A? A can be connected to B, to C, to D and E, but A will not be connected to itself. So it will be, for A it is 5 minus 1, because A cannot be included. A can be connected to 4 cities. How many roads required now to connect B? B is already connected to A, so no need of taking another road. So B can be connected to C, D and E. So now you have got 5 minus 2, which is equal to 3. Now after connecting A and B with all cities, we have the third city C. C is already connected to B and A. Now the number of cities, the cities to be connected are C to D and C to E. So C can be connected to 5 minus 3 is equal to 2 cities. And how many cities are left for D? There is only one, because D is already connected to A, B and C. So D will connect to E. D can be connected to 5 minus 4 is equal to 1 city. And what about E? E is already connected. See, already D, C, B and A have connected. So E is already connected. 5 minus 5 is equal to 0. Now the total number of roads, if you just count 4 plus 3 plus 2 plus 1 plus 0. So this is equal to 3 plus 3 6 plus 4 10. So there are a total of 10 roads, and out of these 10 roads, how many of them are outer roads? The outer roads are exactly 5. You can see that A, B, C, D, E are 5 cities, and the 5 cities have 5 outer ring roads. So number of outer roads is equal to 5. So how many inner roads will be there? A to C, you know that the immediate city has the side, that is the outer road, but the roads that connect the alternating ones, one after the other, then you get from A you will have a C and a D, 2. From B you can have D and E, another 2, and from C you can have only 1. So there will be 5. And also if you now total number of roads, if you write total number of rows is 10 and outer rows are 5, so number of inner rows will be, just subtract them. So this is the way how we finalize the number of rows connecting 5 cities, total number of rows, outer rows and inner rows. And this problem can be transformed into another problem when it is when we talk about polygons. If there is a polygon of 5 sides, or if there are 5 vertices, there are 5 vertices A, B, C, D and E. So how many straight lines can be used to join them? Or a polygon of 5 sides have some sides like this, AB, BC, CD and DE. There are 5 sides, and according to this problem, when there are cities, these are roads, and when there are vertices, these are sides and these are the diagonals. See, 1, 2, 3, 4. What is the other one left? From A there are AC and AD, from B there are BD and BE, and from C there is CE. So there are 5 diagonals. We can just write in the similar fashion the number of sides will be 5 because they are connecting 5 vertices. Total number of sides, number of lines is, you know that A is connected to 4, B to 3, C to 2, D to 1 and E to 0, and total it is 10. So total number of lines is 10, number of sides is 5, number of diagonals will be 10 minus 5. 10 minus 5 is equal to 5. So the same problem, just in another language. We have the two problems covered now: polygon of n sides and polygon and road problem. So this was the application of counting principle in problems, and with this you can complete first exercise in the permutation combination. And in the previous class I had talked of the number of ways in which a person can enter and exit a film hall, a cinema hall. The number of ways to enter is 4 and to exit is 4, so 4 into 4 is equal to 16. And this is the relation type. And the function type, there are 4 roads, and each door, there are 4 doors, and each door has 2 options. It will allow you to enter a room, enter the cinema hall, or exit from it. So 4 square is the choice. This was the number of functions. So this is all about the first exercise that concentrates on counting principle. In the next class we shall go for permutations and the use of PNR, NPR, the factorial n, all other things. And if you enjoyed this video, please like it and subscribe my channel Subhas Classes. Thank you. Bye.